Let's implement bridge VLAN filtering in MikroTik. So in this MikroTik fundamentals video, we will implement bridge VLAN filtering. So we will start with a discussion or a brief discussion with our network topology that will be used for our demonstration. We will then demo how to create multiple bridges and in trying to achieve our objective in our multiple broadcast domain. And finally, we will make use of bridge VLAN filtering, bridge virtual local area network filtering in order to achieve the same result to have multiple broadcast domains. So here we have a basic network topology wherein our MikroTik is connected to two computers depicting two local area networks. However, they are on the same network subnet or addressing scheme is on the same network 192.168.1.0 network. So the PC number 1 is 192.168.1.100 and 192.168.1.200 for our PC number 2. However, we will want our PC to not communicate with one another. So try to create a scenario wherein PC number 1 and PC number 2 are on different local area networks. Okay, so we have our demonstration here using GNS3. So we will implement using multiple bridges. So as you can see, we have our two PC. They are currently addressed as 192.168.1.100 and 192.168.1.200. So they are connected to the same MikroTik. So on Ether 2 and Ether 4. So we have our win box here so that we could configure our MikroTik. So basically the objective is the two computers would not communicate to one another. So if we will perform a simple ping test, so PC1 should not be able to reach PC number 2. Before we go to our MikroTik, let's verify first the IP address if it's correctly set up on our PC number 1. So basically, we'll just show IP. So this is not a Windows or Linux computer or virtual machine. So as you can see, you have this show IP, a different command. Normally, we'll use ipconfig or if config. So basically, the objective is to take a look at our IP address. So it's correct, 192.168.1.100. We don't have any gateway because we'll just try to implement layer 2 connectivity, or we would not try to reach different networks in our demonstration. So let's go to PC number 2 this time and perform the same command, show IP. So it is correctly addressed 192.168.1.200. Okay, so there you go. You have our computers that are already correctly addressed. Okay, so I'm now inside our MikroTik number 1 or MT-1. So I make use of Winbox utility or tool. So we'll focus our attention for this demonstration on the bridge menu. So if we click on the bridge menu, so as you could see, we don't have any bridge interface or bridge setup here. So you don't have any ports assigned to the bridge, obviously, and you don't have any other configurations for our bridge. We will create our bridge. So a bridge, so basically it's a computer networking terminology. So when you create a bridge, so basically you are creating a logical grouping of computers or endpoints, and they will be on the same broadcast domain. So they can talk on the layer 2 or data link layer. So for MikroTik, we'll just go to the bridge menu and go to the bridge tab and click the plus sign. So just leave the name as default, bridge number 1 or bridge 1. So on the ports tab, we'll add the member ports or interfaces on that particular bridge. So for our topology, we have Ether 2. So click OK. And let's add the second port, which is Ether 4. So on bridge number 1. So if we take a look back on our topology, our two computers are connected on Ether 2 and Ether 4. So therefore, we will have the ports 2 and 4 for our bridge interface. So obviously, you could add more ports to the bridge. So for example, we'll add Ether 3 and Ether 5. But then again, for our simple demonstration for this particular video, we will only use or make use of Ether 2 and Ether 4. So now that the bridge is created, so let's perform a simple test. So if PC1 is able to communicate to PC number 2, so by the use of the ping utility or ping command, so this is PC number 1, so this is 192.168.1.100. So obviously we will try to reach the other computer, which is 192.168.1.200. So there is now a reply. If you could see the the output, there is a reply from 192.168.1.200, wherein this is really true because we are on the same bridge interface. We have only one bridge, and Ether 2 and Ether 4 are members on that particular bridge. So there is communication between our computers. However, our objective for this demonstration is we don't want our PC1 to communicate to PC2 or vice versa. So we will implement a scenario wherein this PC number 1 is on a different LAN. So perhaps it is using the /25 or the bottom subnet of a /24, which is from 192.168.1.1 to 1.26. So this is will form our LAN A. So PC2 is on the second half or the upper addressing of the /25, wherein it starts with 1.129 or 192.168.1.129 down to 192.168.1.254. So when that happens, so this PC1 and PC2 should be on different LAN, and how we will implement it on our layer 2. So we go back to our MikroTik. So we go to the bridge menu. As you can see, we still have our configuration intact. So we will create multiple bridges. So meaning to say, we should have another bridge for LAN B. So for bridge number 1, we will assign it to LAN A, which is on Ether 2. And bridge number 2 with the port assignment of Ether 4, and that is connected to our PC number 2. So we will proceed to create another bridge. So we will accept the default naming, which is bridge number 2. So we are fine with it. So ports. So simply assign or reassign the Ether 4 on the new bridge because this is already correct. Ether 2 is on bridge number 1. Ether 4 should be on bridge number 2. So what I just did is double click on the port, and under the bridge selection. So drop down. So we'll have the bridge to choice now, and we'll click OK. So now let's see the effect of having another bridge. So let's take a look if there is still connectivity between two computers now that PC1 is connected or is assigned on bridge number 1 and PC2 is assigned on bridge number 2. So take note, we have not changed any IP address on our computers. So they remain to be 192.168.1.100, and if we take a look at PC number 2, it will still remain 192.168.1.200. But this time, let's verify via our ping command if we are able to reach our PC number 2. Okay, so it says now not reachable. So a while ago, when there is only a single bridge, our computers will be able to reach one another. But now this time with multiple bridge or another bridge, now the PC1 is unable to reach our PC2. So therefore, we have achieved our objective that LAN A would not be able to talk to LAN B in the data link layer or at least on layer 2. For our scenario, we have PC1 and PC2, they are not able to reach. So that is the simple solution on how we can separate our two local area network. So we have LAN A and LAN B. So our LAN A is connected on port number 2 and it is assigned on bridge number 1. And we have our LAN B, which is connected on Ether 4, and this Ether 4 is assigned on bridge number 2. So if you have more ports that are available for your MikroTik device, so therefore you could create more bridge or more bridges and assign whatever local area network you wanted to have. For instance, you have a separate bridge for your hotspot, for your PPPoE, for your home network. Sometimes in networking, so though as simple as it is to configure, but not every simple solution will be the ideal or the appropriate solution that we will implement in production. So a while ago, we have implemented multiple bridges to at least create more broadcast domain on our network. So we have created two broadcast domains by creating two bridges. So this time, we'll make use of bridge VLAN to achieve the same result wherein we have our LAN A and LAN B and we have two broadcast domains still. Okay, so we are now at MT number 2, MT-2, our second MikroTik for our demonstration. So still we will focus our attention on the bridge menu. So we'll create the bridge. So we'll accept the default name, bridge 1, and assign the ports for this particular bridge. So in our case, we have Ether 2 and we'll have also Ether 4 on the same bridge. So this is similar to our demonstration a while ago. However, we will now be implementing bridge VLAN. So we have the VLAN tab here to add our VLANs. So VLAN stands for Virtual Local Area Network. So basically, we'll create more broadcast domains or virtual local area networks from the naming itself. So we'll have to add a VLAN ID each for our VLAN. So we have VLAN 10 for our example. So we have tag and untag, and we will have more discussions on this on the future. But for now, so the port that is assigned to the computer or the endpoint. So we'll assign it with the untag, so it's ether2. Okay, so we will just assume that it is an endpoint or a straightaway computer or printer that is connected to that particular bridge. Obviously, if it's a different endpoint, it could be a switch, it could be an access point, then it could be a different story with our untag and tag. But for now, I will not confuse you for these terms. So for our endpoints, we just connect it to the untag, which is ether2. Okay, so click OK, and on our bridge number 1, we will create another VLAN, this time with a VLAN ID 20, and untag on the port number 4 or ether 4. Okay, so the end result is bridge number 1 is on VLAN 10, and the untag is the ether2. Bridge number 1 will still have another VLAN, which is VLAN ID number 20, and the untag is ether4. So this is not yet the end configuration. We'll still need to go back to our ports. So this time, our ports, we only add the port to the bridge. We haven't gone to the VLAN tab of the port configuration. So we have the PVID or the port VLAN assignment. So as you know, Ether2 is on VLAN 10. Okay, so the default VLAN or the native VLAN is VLAN 1. So that is why we have 1 here. So on our port number 2, it is now already configured to VLAN 10. So we will do it on our Ether 4, but this time it's VLAN 20. Okay, so the final step is to enable the bridge VLAN filtering. Okay, so to enable the bridge VLAN filtering, but be careful, obviously, if your computer is connected to the port or a group of ports that is assigned to the VLAN, you may lose your connection or access to this particular MikroTik. So we will have more on those topics wherein we will discuss the management VLAN for management access. But for this time, so we'll just enable the VLAN filtering. So we'll accept the default values here. So click OK. Okay. So now let's verify if our PC number 3, which is on the same network, the current IP addressing scheme is on the same network, 192.168.1.0 network. So PC3 is 192.168.1.100. So let's try to reach 192.168.1.200 PC number 4. So if we run the ping command, we notice that the reply is the host on 192.168.1.200 is not reachable. So now let's prove this time that it is because of our bridge VLAN. So how can we prove? We will uncheck the bridge VLAN filtering in our previous configuration in our MikroTik number 2. So I go back to the MT-2. So under the bridge menu, under the bridge tab, we have a single bridge. So the difference, again, if you'll notice also, is we have a single bridge this time rather than we have multiple bridges. So on the bridge configuration, we will uncheck the VLAN filtering. So let's uncheck that and click OK. Let's go back to our PC number 3, and this time ping again the host PC number 4. And this time, although we have configuration intact, on our port VLAN ID, so which is 10, and we have VLAN databases of VLAN 10 and VLAN 20. Now it is not taking effect, or the VLANs are not taking effect, and there is now a reply because we haven't applied the VLAN on our bridge itself. So if this is on unchecked, or it will remain unchecked, then whatever configurations you have on the ports on VLAN particular will not take effect on the bridge. So that's why the name goes, it's bridge VLAN filtering. So if we will to check this again and click OK, and let's go back to our PC number 3 and run the same ping command. Now there are no communication to the host of our PC number 4. So the VLAN bridge filtering is kicking in or taking effect. Let me show you quickly why we would not prefer the solution of having multiple bridges and implement bridge VLAN, or obviously there are more VLAN configurations and we will configure them, or I will show them to you in the future. But for now, so why we will not implement or apply this multiple bridges solution, although it will also achieve our objective in separating our local area network. So as you can remember, when you create a bridge, you'll assign ports to it. And when you assign a port, for example, Ether2 is assigned on bridge number 1, you'll notice a check here, which is a hardware offload. So every port that is assigned to a bridge is by default, there is a hardware offload check. So hardware offload and hardware offload on our remaining ports. So meaning to say there is a certain chip or a certain hardware that will help our MikroTik in particularly layer 2 communication, so between the members of the bridge. So that is why the term hardware offload. So there's another set of hardware that is helping our MikroTik, which has a CPU. So this is a different uh, hardware than our CPU. So if we go to system resources, we have the CPU MIPS for the hub AC light. So now, even though the hardware offload is checked on our ports, so as you can, just going through the ports, Ether 2, Ether 3, Ether 4, and Ether 5, the hardware offload is checked. However, you'll notice on the flag, okay, although it's inactive, only the first or the this two, which is on bridge number 1 or the first bridge, has the H flag turned on. Okay, so the H flag is for hardware offload. So meaning to say, even though this Ether 4, so my computer is doing a demonstration, is connected on Ether 4, it does not have any H flag. So the moment you create multiple bridges, all of the bridge ports will not have the H, or only few ports that is connected will have the H flag. Obviously, it will have a different scenario wherein if you have more hardware, because there are MikroTik models that have more hardware in terms of our layer 2 for the bridging capability, and we will have some more hardware offload here. But for this case, the hub AC light has only a single chip for its hardware offloading, so therefore only a single bridge among multiple bridges will have the hardware offload turned on. So what is the consequence if only of these two? So meaning to say the interlocal area network, or meaning to say within this local area network, you won't have the advantage of having the hardware offload, and therefore you will be consuming more CPU resources in your communication between or inside this bridge number 2. So in this video, bridge VLAN filtering in MikroTik. So we come up with a network topology wherein we want to have a separate broadcast domain or local area network, and we have our PC1 and PC number 2 to depict or to have that particular scenario. So in our first solution, we have the creation of multiple bridges and to achieve that particular separation of our local area networks. We then go to the bridge VLAN filtering. So ideally, we'll make use of a single bridge and to make use of the VLAN feature that is within our MikroTik. So to achieve the same effect wherein our computers are this time on different local area networks. Also, I've shown you the reason why we may not be able to implement the simple solution, which is just to create multiple bridges on our production network, because we will lose the hardware offload capability. So I hope you find this video helpful, and I would like to thank you for viewing.